Okay, yeah. So we were talking about the constructors, and then the constructors are something wrong. Yeah, now it is correct. So we were talking about the constructors, and as I said, that constructors are also some form of member function of the class. Now it's a special member function, and what is the purpose of a constructor? The purpose of the constructor is to create or build an object. Then the constructor function name is the class name. What is the name of the constructor function? It is the class name. So if you have a class called test, let us say the name is the test. If I write it in this way, uh, class test, then your constructor has to be in the name of test. That is a constraint. You can tell it as a constraint, or it's the syntax of the C++ programming. So that's about your uh, like naming of the constructor. And most importantly, constructor should not have any return type. So that means if you we talked that constructor is a special function or special method, but when you talk about a special function, it can have a signature like integer, double, and correspondingly it has a return type. It can have a return type, but if you think about constructor, constructor is a special function that does not have any return type. Even you cannot specify a function, specify a constructor with the notation void. So it will be a very unique special type of function. Let's see some example. We'll do, of course. So you can see here, like this is the way you define the constructor. So rather than showing the code on the slide, we can always do it on our VS Code. So let's create a new file, cpp construct example. So .cpp. Let's say this is the file name. It's a strange file name, but yeah, I mean that serves the purpose. So let's say this is our file name, and then we have to define the constructor there. So how do we go about that? So basically, let us say we have that, and then let's say we are creating a class, and first of all, we can do include. What am I doing? Okay, include IO stream, and then we can do using namespace std, and then we can do create a class. Maybe the class name is demo, and then as usual, let's define the class. We can do the public and private functions, but let's make it very simple. Let's only focus on constructor. So we do public. I'm going through the details of why I'm writing certain things. So this is your signature of the constructor. This is the prototype of your constructor function. One thing we missed, that is a semicolon sign. So once you are defined, this is your basic definition of the class, let us say. So this is your constructor. So then you can define your constructor in this way, following the C++ syntax, demo double colon, and then you do demo. This is the function. You can do cout. This is the constructor. Okay. So this is the body of the constructor function. And then we can instantiate the class. It's very simple. Int main. We can do return 0. And then we can do demo, and then we can say demo object. This is the instance of the class. And then, once we do that, as I said, on principle, this constructor should be called. Let's verify what happens. So let's write this is a demo program. Okay. So it's very simple. There is nothing in it. So what we did, we created a simple code, and then we use the include. We defined a class demo following the C++ syntax, and then we define the constructor. This is the prototype, or this is the signature of the constructor function, and then we define the function in this way. So, and as usual, we are following C++ syntax. We are putting the class name demo double colon demo, and then we are writing something so that we can feel, we can sense that constructor is called. Now, if we simply create the terminal, and then we can compile this particular code g++, and then we can say dash o c.exe, that is the constructor.exe, and we can say cpp, what's happening, cpp construct, why it is not, so maybe I need to redefine it. Cpp construct exam.cpp. Oh, no such file name. Oh, I did not, probably I did not save it. Oh, that's the problem. So that should not be like that. It is a problem. I should not be using it in that folder. So let me go to the current folder. So let me go here, classworks, and then create a file. Probably that's why it happened. Demo constructor.cpp, and then we can just paste it, whatever we created. So now we saved it. Now let's say we do demo. Okay, now it works. So if we do that, if we run this code, you can see that this is the constructor. This part is created. I mean, we did not call this function, but we just instantiated the class, and that creates the constructor. So it is related to the C++ compiler. Compiler knows that whenever you create the constructor, a special function in this form, then it will be called whenever the class is instantiated. So this is how the constructor works. So if you have any questions, this is the time you should ask the question. But this is the way the constructor work. And usually most of the cases we put the constructor as a public. Very rare situation we create private constructor, but those are very complex programming scenarios. But constructors are mostly public, so that you can access it from anybody else, can any other object can instant use your object. That's why you do the constructor. Okay, so that's about it. Now, okay, so now let's move on. So we learned a little bit about the constructor. So if we move on, so then you can always have, I mean, modular programming module. Let's not uh, let's not stress out with all the complexities at this point. So, I mean, you can, if you there are some properties of the C++. I mean, if you this is not constructor, but you can use in place initialization if you use C++ 11 or later. If you are using modern compiler, you are using this one. So you can initialize the member variable in its declaration statement itself. This is not new. I mean, this is running since a long time. So You should be able to use it without any problem. So, the thing is, sometimes we define constructor, sometimes we don't. What happens? So, if you don't define a constructor, then you use a default constructor. Now, a default constructor is a constructor that takes no arguments. Excuse me for a second, my dog is barking excessively. Just a second, I'm sorry for that. Sorry. So, sometimes you have a constructor and sometimes you don't have a constructor defined explicitly in the program. For example, if you use the same class, okay, um, let's pull up the same example. Let's say we use here, we don't use the constructor at all here. Let's say, let's say, and we can do a function int. I'm just writing a random function int do or int not int void do comment, and then we can do string xyz. Okay, and we have to include string. So if we do like that, um, here void do comment, and then following the same syntax of the C++ demo, and then we do comment string xyz. So you have to pass xyz pretty much. So it should be demo, it should be void actually. And then you can say cout, let's say xyz. Whatever comment you were passing, it will just publish the comment. So in that case, you still have to instantiate the function. And then if you do demo object dot do comment, you write hello world, you know, that way you should be able to run the program in this way. So you see here, you are just passing the comment. So what happens here, the class uses a constructor. We do not define a constructor, but still the class uses a constructor. If you don't define, as a programmer, if you don't define a constructor, your compiler will give one to the class. So that's what happened here. So there is a default. This scenario is called a default constructor. But basically, whenever you create the class, If you have your constructor in mind, then you define your constructor. Otherwise, your program will, your C++ compiler will create one for you. So that will be a part of the C++ object. And then once you execute this statement, the first one, line number 18, your default constructor will be executed. So it will be, the class will be instantiated. So constructor means creator of the class. So that's why you need the default constructor, and then you can move forward with the regular stuff. But constructor can be used in different ways. Um, Another example, let's say we have some private function, private, not function, private variables. Let's say int x, and we have int y. Okay, but the thing is, let's say this demo is something that depends on x and y, so you really need to initialize these variables. So that's why you can use this way: 0 x equals 0, y equals 0, because you are using advanced C++ compiler. So you can do that. but what happens if you want to use different values for x and y? So in that case, there are two options. I mean, you can have certain public functions. You can do like int get x, and then void set x, and also set x, and then you can have int x. Same way, you can create something like y, get y, and set y. It's very straightforward. You could do that. And then within the demo, what you can do, you can have another function, uh, void demo double colon set x int x, and then you can say, sorry, you can say um, this dot x equals x. This function means this particular object. I mean, whatever object we are talking about here. So what happens here? Let's see. Demo has no member set x. So what's happening? Void set x is, oh, I'm sorry. This one is broken. So now it has. So this is not there. Demo, this expression master cluster that has the demo. So what happens to this? Let's do it in this way only. X equals x. So this x, let me call it ax. A means like argument x. So we can say x equals ax. So this x means here. This is the x, the private member function. Now you can use the same thing for the set y. I'm trying to make it as simple as possible. It may be done in faster way, it may be done in a more slicker way, but I'm trying to make it easier to understand. So y, and then you can do ay, you know. So what happened now this time? There is no member called set y. So why it is okay? Now it should be good. Sometimes we have those issues. Okay, now it should be good. So these functions we have defined get and set functions. Now similarly we can define the get functions. So we can do int demo colon colon. You can say get x. You can do return x. So when you do the return x, it basically returns this x, whatever value it assumes. You can change the values during the course of the object. Now you can do another function get y, and then you can return the y. So then you have the full definition of the class. You have everything defined. But I mean, you can define a constructor as well. That constructor will be used to instantiate the variables of the class. I mean, by definition, constructor should build the class, so that means it will structure the class. It will set the internal structure of the class from the beginning. So how it does? So basically, you can say that demo, and then you can say um, int ax, int ay, and then you can say that x equals ax, y equals ay. Now you can have it default constructor as well, demo. You can do it in this way. So you know what I did? I defined the constructor in line. You don't have to do that. I mean, you can do it in this way as well. Let's do it in a cleaner way only. So you can have it that way. And then here you can define the constructor in a very simple way. So go to the top before the void. There is no necessary, it's not necessary that you have to define it in the as a first function. It is not needed, but I'm doing it as a part of good good coding practice. So we can do demo. So that is an indicator that it's a constructor. It's a constructor. So we can define the first constructor without nothing. I mean, it will not. We can say this is a simple constructor. No argument is passed here. But then you can have the constructor where you want to initialize the variables. So here is how you can do it. So you can do demo int ax, int ay, and then you can define the variables. So you can do x equals ax and y equals ay, you know, and then we can say that uh, x equals, I mean, you have equated x to be equal to, in this particular constructor, um, ax and y equals ay end line. So basically you say that you have defined the, I mean, your constructor is like that. So now if you create the object, let's say you create the object demo obj. I mean, this is one function and you do the hello world. I'm not disturbing this flow at all. But then we can call the other constructor. We can say demo. That is the same because this is the class name. But then we can say uh, demo object 2. This is the second object where we are defining the, I mean, this second constructor, this one, this detail constructor. It is called overloaded constructor as well. So you can say uh, 2.0, sorry, not 2.0, 2 and 4. Let's say this is 2 and 4 because 2.0 is not allowed because it's an integer. So once you do that, now if you go there and do uh, demo object 2, let's say get x and then get y, demo object 2 dot get y, you should be you should see the revised values. So in this case, I mean, you can do it here as well. We can see the difference. I mean, you can use demo object here because that is the object we have created here. This one. This is the demo object and this is the overloaded constructor. I have called it here. So then if I compile it and try to run the program, you can see the difference. So let's do it little comprehensively. So this one. So you see, first of all, here Your hello world is still there, but you are calling the simple constructor. So your simple constructor is called. So that is the default constructor pretty much. So it is called, and then you see 0 and 0. Why? Because you have these properties x and y, but they are defined as 0 to be beginning. I mean, by default, the class has set up these values to be 0 and 0. That's why you see 0 and 0 here. But then you define your own constructor, I mean overloaded constructor. You set x equals 2, y equals 4, and then you can see that this one is called, the overloaded constructor is called here. You set the values here, and you can see immediately that if you do the C out, you get 2 and 4 for x and y. So basically that is why you want to use, sometimes you want to use the overloaded constructor versus the default constructor. The overloaded constructors are very, I mean, they are comprehensive because in a sense that they will generate your constructor, they will reinitialize your internal data structure for the class, whatever you want to do when you define the constructor. I mean, unless you write explicitly what to initialize, it will not go into the code and discover itself. So that's how you define the constructor. So in this example that we discussed just now, we defined the default constructor, then we defined the simple, just a no argument constructor. We defined itself. You can ask the question, why in the world you need to define it? I mean, it's a default constructor. Let's switch it off. I mean, if we don't use it, let's switch it off. Let's say we don't use it, and now let's try to run the code. Let's see what happens. I compile it and I run it. So there is no different. I mean, it won't be different. So why it is saying simple constructor is there? Oh, I did not save it. The reason. So if I just do it, you can see here that no matching function call for demo. So what is demo? What's happening here? 24.1. Yeah, that's the problem because here what happens, uh, so if you define an overloaded constructor, you have to define your default constructor by yourself. Otherwise, it won't work. I mean, it will throw some compiler error. This is the contract that you are making with your C++ compiler. So now it works. So the thing is, if you can ask the question, why in the world I am doing this default constructor? In the past, and that goes to the version of the program. In the past, for example, you have it is 0, it is 0. I mean, in the past, in the legacy C++ compilers, this feature was not available. At that point, you needed this function. I mean, you can use this function for other purposes as well. There are endless purposes for defining this default constructor. You are not using this class for you are not using C++ classes just for doing some simple definitions like that or simple calculations like that. There can be multiple things going on there. You can have a database connection. You want to instantiate your database connection within your default constructor and so on and so on. So there is no limit of the requirements. But if you have somehow if you have this defined in this way, you know suppose you defined in this way and you did not initialize the variables, then your default constructor provides a way to define them. 0 y equals 0. So if you do that and then if you compile the code, let's clear it so that this becomes a little bit more visible. So if you clear it and then if you run it, so you can see the same thing. But here, the default constructor is doing some work, at least for you. So as I said, default constructor can do endless number of requirements. So it depends on how you define your class and what is the requirement for writing this class, So those are the important things you need to consider when you write a constructor. So what we learned here is that first of all, you need a constructor in the C++ class. Whenever you create an object, there must be a constructor. Now, maybe you are not defining the constructor. In that case, compiler will give you one. That is called default constructor. But sometimes you may want to define that default constructor itself. And the reason for that can be multiple, like you want to execute certain amount of code within the constructor. You may want to do that. You can do a lot of things there. You can initialize certain variables. Now, along with the default constructor, you can define multiple constructor. And if you define more than one constructor in the class, the other constructors which are not default constructors, means they have some arguments, those constructors are called overloaded constructor. And this process is called constructor overload. So when you do the constructor overload, you have opportunity to write some code within the constructor. And then what happens here, that whenever your class is instantiated, those pieces of code are executing. So that means you are writing some code when you are writing a constructor. So that is the necessity for the constructor. Now, this is the syntax for defining the constructor. Implementing the constructor. This is the syntax for just putting just writing the signature of the constructor. The main, the signature of the function itself, prototype. Then you have to define the details. Now you have options like you can do what you can do. You can have multiple options here. We have done before, you can choose to write a demo.h. You know, it's simple. It's like a game with your programming. Just you can go there, and then what you can do, basically, what's happening here? Am I? Oh, sorry. So constructor, where did it go? Demo, yeah, here. So what you can do here is basically you can define it inside your .h object, .h module here. Now you go to, you can create another file called, let's say, demo.cpp. And inside the demo.cpp, what you can do, basically, I'm trying to modularize the code. That's the goal here. You can define this, and then you can go there and define this. And then along with that, you can do include demo.h, So you can define this one, and then you can redefine, you can not redefine, you can include this code, these pieces of code inside your demo.c cpp. So that's your implementation of the class. There can be more. I did not include the full story here. Yeah, these are the things, because these are all part of the class definition. Main is never part of the class definition. So that is not a good programming style, to write the main program in the same code where you define the class. So this is your implementation of the class. Now you go to the main program here. What you can do, first of all, you can get rid of everything from here. Um, you don't need it at all. And then you can do include demo.h. So that way it knows about the definition. Now, when you compile, though, you have to include that uh, demo.cpp here, because it needs to know, compiler needs to know how the constructor was, um, I mean, defined, how the functions were implemented. So once you do that, now you define c.exe, you can see the same result, exactly same result. But with a much better modularity. So your .h file is called the header file. Again, I mean, we are repeating the same concept again and again to make ourselves more and more familiar with programming. So you can define the .h file, and then you do this. Then then you write all the prototypes here. This is for the prototypes and declaration of your variables. Then you go to demo.cpp, where you have the detailed implementation of your number one constructor, number two all the functions that you are using in this program. So these are the implementation and I mean defining everything. So and then you go to your actual implementation, which contains the main function. I mean, this is like a third person function. I mean, as a if you think about more modern terminology, you can treat demo.h as your API. So you don't need to know how this is implemented. In this API, you can create some documentation saying that if what get X, what get Y will return to you. How do you define set X? I mean, it's self-explanatory, but still you can explain that. And what is this do comment? So all the function names you can see here, they're very self-explanatory. This is another thing you should learn as a part of your programming effort. Where in order to be a great engineer, if in order to be a good engineer, you have to write the good code, write code and efficient code. For being a great engineer, great software engineer, you have to write the functions in a way, or you have to define the variables in a way that matches your domain of requirements. Let's say, I mean, here exactly, you see, we are trying to comment something. So we are writing do comment, and then you do get X. So we want to get the value of X or set the value of X. So this, I mean, programming functions should be in a way that you don't need to put a lot of comments there. You know, these days, I mean, if you think about the best practices in the software programming, you will see the first thing they would tell you that if you write too many comments in a code, that means your code, it is called code smell. Too many comment is not good. I mean, it's not good to maintain. I personally encountered, I mean, different programmers, of course, they have different choices. I personally encountered a situation when I started doing work for a for a team, and then I discovered that nobody deletes anything from the code, you know. Even if it is in the version control, standard version control, people just comment out their code and then they implement the new code. I mean, I don't know why people do that sometimes, but commenting out the non-usable code does not make sense if you have a version controls framework. Maybe they don't want to work, and they don't want to, I mean, they don't want to work harder to fetch what was there before. They want to put all the history within the code, but that defeats the purpose of your version control framework. So that is called code smell. If you put a lot of comments in a code, that is code smell. Why do they call code smell? Because you know, if you go to a kitchen and if it smells bad, then you won't want to stay there longer. You won't enjoy. So similarly for code, if you go there and see a lot of comments, I mean huge, a lot of codes commented out, then you will, I mean, it will give you a pushback. I mean, like how to uh, how to find out what do I fix. I mean, that code will become more and I mean, in terms of number of lines, that will expand over time, and you will see that at some point that is a 5,000 lines of code, out of which 2,000 lines are commented out. So it does not make any sense. And also the commented out lines are random. I mean, in between the code, all on a sudden you see a lot of lines are commented. So when you do a search for the code using some keyword, those commented out lines will show up, and then that will confuse you. That will make your troubleshooting very harder, your maintenance for the code very harder. So that's why that came up. So anyways, so this is called the API. This you can use this .h file as your API. So we have learned enough about the constructor. Let's move forward. We talked about the default constructor, so we talked about this one as well. So now comes the destructors. So before we discuss the destructors, so any question about the constructors? So okay, so if there is no more question, let's give a quick break, and after the break we will resume and discuss the remaining stuff, the destructors. So we are going to study about the destructors now. So what are the destructors? First of all, I mean, like the constructors, they are also, I mean, destructors are also member function of the class. Destructor, there cannot be more than one destructor. Can be member function of the class. I mean, they are automatically called again, like the constructor. They are also automatically called when you want to destroy an object. So destructor name is the syntax that you should be using to define destructor is like that. You have to use a tilde sign like this one, class name. So for rectangle class, it should be like this. Again, like the constructor, destructor does not have any return type. And the difference between the constructor and destructor, significant difference is unlike constructors, destructors cannot take any um, arguments. You know, destructor does not have any arguments. Only one destructor is allowed per class. So a class cannot have more than one destructor. So it cannot be overloaded. That means, and if the constructor allocates dynamic memory, then the destructor should release it. So we talked a lot about the dynamic memory allocation. I mean, in fact, you know, whenever you are coding with C++, people are scared of the dynamic memory, but it's not a scary thing. I mean, it's a simple scheme. I mean, all the programming interfaces, they handle the dynamic memory some way. I mean, people, I mean, if you are talking about Java programming, they assign that memory handling to the JVM. But you know, in the inside the JVM, they make up some code that essentially handles this. I mean, destroying the objects and reclaiming the memories. But in C++, good thing is that it's very transparent. You know, if you are a C++ programmer, then you are writing the code in an extremely transparent way, so you can you can see yourself that how you are creating the object, how you are destroying the object. So that's a great feature of C++. I mean, that's why actually, you know, I mean, professionally, if you are trained in C++, you should be good in learning any other like object-oriented language. So that's a good plus point for C++, and that's why there are so many prerequisites around the C++ programming for many disciplines. Like if you want to do some data science major, for example, I mean, in most of the UCs, they will want you to go through some C++ class. Um, so that's the context. I mean, that's a different context of C++. But let's move forward with the destructor. Let's create an example of that. So let's come here and then let's create a class called cpp underscore destruct dot cpp. So this is our class, and again, I mean, business as usual. Let's create the include, I mean, IO stream itself. So if you do that, and then you can, I mean, we can use the demo class itself. So we should not have created any new class, but let's write it from the scratch. It looks good. So if you do that, and then your class, the skeleton of your class, you need a semicolon here, and then you go back here and you write your constructor first. So you write public, and then you write demo, that is your constructor, you know, and then you define the destructor, and this is the way you should define it, demo. So that's your destructor. So the first one is the constructor, the second one is the destructor. So what is happening with so many things are going on? Okay, let's see. Let's define those and we'll see how we can accommodate all those errors. So let's define the function itself. So in order to define the function, let's say we are defining the default constructor in this way, you know. So that's, oh, I'm sorry. That's why so many errors. So this way. Now we can define the destructor. It's the same way. When you define destructor, it follows the same syntax. So you can do it in this way. And then comes the main function int main. Um, then you can do return 0, right? And then you can define the class itself. I mean, you can instantiate the object. You can do demo and then you can say demo object. You instantiated the class. Now, so if you do that, let's see what happens. What's the life cycle of the class? So let's do a clear here and then G++ and then we do what's the name of the class? It's a CPP underscore. So G++ dash O d.exe, d for destructor, cpp underscore destructor cpp, and then we can do d.exe. We can so you see here when you do this one, your constructor is instantiated, but then when your program ends, I mean you are going out of the program, demo class is no longer used, out of scope, the destructor is also running. So that is basically demo. You can see here that you don't need to explicitly call destructor at all. You can simply write the desirable code inside the destructor and that's it. I mean, that will do the rest of the things for you. So that's pretty much your destructor stuff. So yeah, I mean, any question around it? So yeah, I mean, let's w- w- probably you remember that we did a lot of dynamic pointers. So destructor is the place where you should do handling of all the dynamic pointers. So just remember that this is the cleanup place. This one is the cleanup place. We'll see. As we walk through the course, we'll show multiple examples of using the destructors. But let's move on for the time being. So, so let's continue with it from the current slide. So yeah, so that's what we are doing now. You can always do that. I mean, you can. I mean, there are multiple functions, multiple examples in the screen. You can have the inventory item class, and then you can you can define the this one, right? The item description, but you are doing it using the pointer. Then you do multiple stuff. I mean, we don't care what you are doing. I mean, this is the part of the header function. So then you, at the end of the day, you are coming here and then you do, you write the program, right? So you did all the programs, but then how the destructor is important in this case. So in this case, I don't see any particular, yeah, this is the destructor. You can see that you are deleting the description. That's the important thing. So here, if you go here, you are creating a dynamic pointer, right? Dynamic memory allocation, dynamic memory allocation, and then at this point you are releasing that dynamic memory. So you're releasing this dynamic memory here. Okay. So whatever you are using throughout the class, like here you are referring to some, pointer. So all the pointers that you use with the description, they are deleted here. So that means your class is, all the pointers are reset basically. So now you can just write the program without any problem. Destructor is automatically called, so no worries anywhere. So the next thing is, the constructor, destructors, and dynamically allocated objects. That's what we were discussing. But you know, when the object is destroyed, its destructor executes this one. So you create this object this way, and then when it is destroyed, the destructor executes the delete function um, here. Now, so we have so any question about the destructor? We will come back to this topic. Don't worry. It's not that this thing will not go away in that simple way. Whenever we will do some more complex examples like the linked list or other different C++ programming examples, some specific data structures within this course, we will come back and we will do a very detailed discussion about the destructor and how we can possibly uh, get rid of the dynamically allocated memories. But this is the very, very simple example. What I, why the destructor? What is the scope of the destructor? What is the perfect use case for the destructor? So that's, you are in order to delete this memory, this object, this dynamic pointer, you have to call the destructor where you can delete it. So next part is the overloading constructors. We already covered a lot about overloading constructors. Remember our X, Y. We did discuss about it. So I'm not going through the details about this thing. Um, so there can be this is important because your constructor a class can have more than one constructor. I showed you about the two constructors, but this example basically shows you multiple constructors. You have constructor 1, constructor 2, for example. You can have more constructors here. So here you can see that your first constructor, as it says, constructors function is to initialize your class. That's what it does. It creates empty name, email, and phone for this contact class. Whereas this one, number two, basically creates some placeholder. Not placeholder. It creates some like whatever you want it to be created. You instantiate a contact. You create a new contact. Let's say you are creating a phone book application and you create a new contact and then you use this second constructor number two, not the default one, the second one. So this is number one, this is number two. You are using the constructor number two and then you pass your specific arguments. Um, so that's what you can do. You that's how you can delegate a constructor to do certain things. That's how the constructor delegation is so important. So you can see here that both the constructors, the first one, number one, and number two, they are doing the same job. I mean, functionally, they are doing the same job. Programmatically, they are setting the value of name, email, and phone. But number two, the default constructor simply apply some empty strings. That means their default constructor is for your placeholder value or default values. But your second constructor, they assign the specific values. So that's how you delegate a constructor to serve your business purpose. Now, it is possible for in the advanced constructor, it is possible for one constructor to call another constructor in the same class, you know. So here you can see clearly that your first constructor, this one, constructor number one, this is number one. Instead of going into there and setting the name equals blank, email equals blank, phone equals blank, it can call the second constructor itself here like this in the advanced. I mean, if you use the programming, I mean, if you program your C++ code using your own, I mean, new VS Code compiler, it will be like that. And then if you can see here that this is the delegated constructor anyways, overloaded constructor, but this is a programming pattern that C++ supports as well. So this is this is known as constructor delegation. So basically you are delegating the task of this particular constructor into here. So this is called the constructor delegation. So, you know, for a class, you are allowed to have only one default constructor. That means this is your default constructor. This is the name of the class and this is your default constructor. You cannot have more than one default constructor. You cannot just create more than one function with the same signature. So that's why you cannot have more than one default constructor. But you can have more than one like overloaded constructor. But here, for example, square, I'm sorry, this one won't compile. It's very simple because int is not a variable, it's a data type, so it will not compile. So anyways, and also a class, only one destructor is allowed, only one default constructor is allowed. Now, like the constructor, you can also overload the functions. I mean, you can have multiple functions like we showed the example set y. It may be so that inside the set y function you are inviting multiple inputs, or I mean you are inviting multiple, you are allowing multiple calculations. Maybe your y can be modified. I mean, in one option maybe you are going to give set y, you are passing the default value of y, and then second implementation you can have set y, and then you can set a flag onto it that will basically square the y. I mean, there are multiple endless requirements, so that's why C++ does support overloading of functions as well. you know Non-constructor functions can also be overloaded. But in order that a function is overloaded, you cannot just write void set cost double and then another void set cost double. I mean, same signature, everything same. You cannot keep identically defined two functions. That will cause compiler error. They should be different. The parameter lists must be different. So the parameter list for any overloaded constructor must be unique. They should be different from each other. Otherwise, you will get compiler error. So you can use the private member function as well. Like member functions. So far, we have learned that we have the private variables and then we have public functions. But there is no limit whenever you write C++ code. Let's say we uh, let's give an example. So here I'm just using this class, picking up this class for our demo. So let's say we are using this one. I mean, I can go with demo.h, then demo.cpp, and demo constructor.cpp. So I'm trying to show you that different, I mean, we were talking about, of course, we are talking about the overloading, but within that context, within the context of the overloading, we were talking about, just a second. I have to again reshare. Yeah. So we are talking about private member function. So in order to support the private member function, let's say we have demo.h, and then under the private, so far we have these variables only, but you can have the function as well. You can write, let's say, private member functions are for the private use within the class only. Outside members cannot access the private member functions. So let's say we do we create the private member function as uh, like print, let's say void um, do print, and then we can do int x, int y. What it does in our case is that uh, let's say there is a requirement whenever you like within the constructor, whenever we implement the constructor here, we are doing the C out. Without doing that, let's do like here. This is the C out. Let's say we can use the private function. For using the private function, you don't have to instantiate the class at all. You can use it as is, like a normal function here, normal variable. You can use the private function here. So you can do print, and then you can say x and y. So then you are eliminating a lot of busy works. I mean, this is essentially for usage within the function itself. So if you just compile it, what's happening? Oh, I did not save something or what. So let's see. Undefined do print. Okay, so what is the do print? So why it caused the problem for us? So we have, oh, I see, do print, and then we have, so we define the do print here. That's not a problem. But then demo.cppo, I see. We have to define the do print. Otherwise, how it will work? So let's say we have to define demo do. Um, so we can do print. Sorry, void demo. Where does it go? The do print. Just a second. So if we go back here, no, not this one. I wanted to do it here. Let's do the inline definition of the function. So we can do cout, let's say x equals x and y equals y. So if you do that, and now if you go to the here, this place, now you should be able to compile it. So if you do that, so it compiles. So now you can execute c.exe. So then you can see clearly that this one do comment, I mean within the demo, whenever you call the demo, it is printing up the stuff. I mean it is doing the do print here. It is calling this one. So whenever you call this second constructor that is inside here, whenever you call the overloaded constructor basically. So what is this? Not this one, this one. So whenever you call this one, so you are calling essentially the overloaded constructor where you are basically calling that this do print function. So, but now if you cannot just call the do print function from here, you cannot just do uh, demo object 2 or object 1, whatever you call, you cannot get access to do print. It's not visible to you at all because it's a private function. So private functions are for providing certain services within the class itself. It's not for outside the class. So that is the necessity of the private function. So let's resume our study. So there is you can create arrays of object. I mean, like objects are nothing but some form of the data types. The integer that can have an array. So the objects, they also constitute certain data types. The only difference is integer, string, these are defined by the programming paradigm itself, C++ programming paradigm. And integer is a primitive data type, whereas these objects are more complex data type. You have multiple, it has multiple member functions. It follows the rules of encapsulation. That's how you define the objects. I mean, string is also an object. I mean, but it is given to you by the compiler. I mean, C++ framework itself. It's a part of the C++ programming language. But string is also inbuilt function, and it is a inbuilt object, and it is a complex object. It has lot of member functions as well as lot of functions, public functions, public functions for you, for programmers to use. So, string can be, there can be array of strings. Similarly, there can be array of your objects. So you can define them exactly the same way as you define the arrays of integer. So for example, if you have a class called inventory item, and let's say you have a store and you have multiple sections of the store, so but every section has inventory items, so you can define multiple inventory item arrays specific to different sections. Now the default constructor for object is used when the array is defined. So basically you have it should use the initializer list to invoke the constructor that takes the argument, you know so otherwise it will not work. We'll go through the more examples. So for example, this one. So let's say we are instantiating. This is nothing but instantiation of the inventory item object, but then when you instantiate, you have to provide it with the specifics of the items. So here you see here that you are creating three inventory items, three an array of inventory items. There are three elements. Each element is one inventory item, and you use it using some constructor. Some it's not a default constructor, it's a user-defined constructor. So that's how you can define the arrays of the object. And I mean, you can do it in that way as well. I mean, you can say it is not necessary to call the same constructor for each object in an array. So you can do multiple constructor here. For this one, this is just a string, and then this is just the constructor like this one, and that way it can move forward. So uh, how do you access the objects in an array? So you have this one inventory. Uh, so you have an array of the object. So you have to identify the individual index of the array. Like for example, if you have an if you have an array defined of, I mean, of array of integers like this one. Let's say you have integer x2, and your definition is something like this. Let's say 1 and 2. So then how do you access the second element of the integer of this array? You simply do x1, right? That's how you access the second element. So same thing goes for inventory, but then this is little complex than your integer, because in this case your inventory class or inventory object that has certain functions. So when you do inventory then 2, that means you are fetching the third element of the inventory object, because 0, 1, 2, that's how the index work. So this is the third element. And third element, what is that third element? It's not integer, it's not string, it's the inventory object, inventory item object. So then you can apply a member function there, and that's how you build it, you know. So basically, if you have multiple students in a class, so you can define an array of students. Each element in that array is a student itself. So then you can apply all the member functions to the each of the element. So here in this case, a more cleaner way to write the code, I mean, this is arguable, but you can do inventory item. This is the class name, and then you can say, let's say item equals inventory 2. So that means this is an inventory item. This is the item. Now you don't use this line. You can use it in this way. Item dot set units. Then you put whatever number. So this is another way to do that. But in that case, you have to write additional lines of code. But this effort is worth it, because as a first time learner, you may be, I mean, if you jump the step and if you want to make lot of dynamicity, create lot of dynamicity in the program, your program at some point may be little bit error prone in the beginning. So you can get rid of that error, I mean, that tendency of creating error by manually creating simple objects like that, defining the identifier like that, and then apply these functions, these member functions to the identifier, rather than calling the individual element dynamically and just apply. I mean, those are both same. Of course, I mean, if you are an advanced programmer, this is the way to go. But when you are learning, what I'm recommending you to use this in this way. So yeah, I mean, you will have within the book, this is from the book, this screenshot is from the book. You will find a lot of examples related to the arrays for constructors. Now, there is a different topic. I mean, unified modeling language. I mean, this is usually a part of the software engineering class, but here we are giving a little introduction to that. So UML, or unified modeling language, I mean, it's a common standard. It's a provide a set of common standard diagrams for graphically describing the object. Whenever you are writing the code as a part of the enterprise, one of the goal, I mean, why I'm telling that, I mean, one of the goal of your C++ class in your college is to make you educated about the programming practices. I mean, although I agree that it should be a part of the introduction to software engineering class, but here is our opportunity to get some little bit of knowledge about, right, about the class diagrams, because whenever you design a class, that's where you will need, whenever you are a software engineer or software developer in an IT company, any company, you are writing some software, you will often need this, create the class diagram just to understand how the things works. So basically, UML diagram for a class has three main sections. So here, the first section in the top, you see what happens here. So this section, it has the class name. So if you write a rectangle class, you write rectangle here. Now the member variables are listed here. Variables means, let's say, integer x, integer y, you list it here. Now member functions are listed here. So whatever, get x, get y, set x, set y, you list it in the third block. Now this is the example. So you can see here. Now we are not very elaborate about which one is private, which one is public yet, but this is a good way to represent a rectangle class. This will, I mean, whenever you show the rectangle class in this way, you can immediately see what is the class name and what are the basic member functions and what are the basic member variables, what are the member functions. That's it. There is nothing outside of these in this class. So UML access specification, for doing the access specification, you can do it in this way. I mean, like you can do minus sign in order to show that these are private, and plus sign when you do a public member. This is very important. I mean, everybody knows, I mean, whoever writes the does the software engineering, they know the UML. When you work for a company, let's say you were joining as an intern, so you should show, I mean, in any company, there is an expectation that interns will be a part of the workforce. I mean, they are no longer treated as student in the company, you know. I mean, if you think that you are working for a company as an intern just to learn something, that is wrong. They also want some output from you, and based on that output your reputation will be built and they will consider your future hiring, considerations for you for a more specific or permanent roles. So basically, you know, here you should know that whenever you create a class using the UML language, the access specification is important, and you use a minus sign for a private member and plus sign for a public member. Now, if you have a private member function, then that should be of plus sign, sorry, minus sign. If you have a public variable, let us say, it is rare, but sometimes you may have, then that should be plus. So the to indicate the data type of the member, you use a colon and then you specify the data type, specific data type. So here there is no clue of the data type, no data type, but here in this way you will show the data types. So to indicate the data type of the functions, you have to use this notation. I mean, you have to use the data, I mean, basically the argument name and then colon and what type of data it is. So if you want to set something as a void function, then it should be like that. Similarly, if it is an integer, yeah, I mean get with, let us say, so it should be something like int. Okay. So yeah, I mean that this is the way, this is the rectangle class. This is the UML representation of the rectangle class. Now you can also show the constructor and destructor. Now constructors and destructors you can use. I mean it's a part of no return. I mean you should not list any return type for the constructors or destructors. So the way should be this way. You should write it in that way, constructor and destructor. So you should still use the colon, but you don't use any return type. That's the normal way to represent a constructor or destructor. So that's about it. That's what we wanted to learn as a part of the class. Hopefully, it is not too hard to you. Usually, people get scared off when they think about advanced C++ course, but we try to make your life little simpler by showing you simple examples. In fact, there is nothing complexity in C++ at all. If you think about those dynamic memory allocation, now you know, like your destructor. So that is the place where you have to use your destructor to 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 reclaim your the memories and deleting the memories and reclaiming the memories. So that's about it. Any question? This is the time you can ask any question. Well, if you don't have any question, then I will see you after the spring break. Let me bring up what is the spring break schedule again. I don't want to leave the class with some dilemma about what is when is the spring break, things like that. Let me open up. the message, specific message from our chair where you can see the spring break. Let's see.